I just wanted to take a minute to talk to you about some of the discussion forums that you've been having. So I've loved them. They're great. I wanted to give you some sort of definite answers. I like that you argued things through, but I wanted you to see just exactly what geologists generally do, and then talk to you a little bit about Earth subsystems. So what you see on the slide here is from the American Geological Institute, or AGI, and this shows you some median annual salaries for geoscience occupations from 2018. So, by and large, I just wanted to give you some big boxes that represent different employment opportunities for geologists. So, geologists definitely work with civil engineers and as environmental engineers, as well as mining and geological engineers and petroleum engineers. Lots of overlap between engineers and geologists. I think some of you mentioned talking about geologists as contractors. They don't generally do that. They work very closely as environmental consultants and consultants in a variety of industries, but not so much in terms of like actual contract work, meaning like building of, I don't know, developments, for example. So if we look back at this slide here, there's a lot of jobs in geology in the environmental science related fields. So there are lots of project managers who work on things like groundwater remediation, soil remediation after there's been contamination, for figuring out where the best way to place to build a road might be. There's lots of jobs for soil scientists, lots of jobs for environmental scientists in general. A lot of times, there's a huge overlap between environmental scientists and hydrogeologists or hydrologists. Hydrologists can include people who study surface water, like lakes and rivers, or groundwater. There's tons of jobs, unfortunately, because there's a lot of pollution in the world that we live in, and that pollution has to be mitigated. And also, there are, like, people need water, and they need fresh water and clean water, so it's an important job. On the other end, and there's certainly plenty of jobs in education. There's not a ton of jobs for what I do. Two-year colleges, it's not a huge job market. I'm a very lucky person. The other sort of end of the spectrum has to do with extraction of minerals, whether that minerals include petroleum, whether it includes rare earth elements like the ones that your phones are made of, whether it includes just basic materials for building and technology. That is certainly the more lucrative part of geology, for sure, but it appeals to some folks and not to others. So I just wanted to, there is a huge demand for geologists. AGI predicts that by the year 2024, that we will actually need in the United States 150,000 more geologists than we will have graduated from our 4-year schools. So those 150,000 jobs will actually be awarded to people who we have to bring in from other countries to fill those positions, because they're really important positions. We need resources as humans, right? We need water, and we need to live in an environment that is safe for us. So all of those things add up to really good job outlooks for geoscientists in general. So that was the first thing I wanted to talk to you about. And the second thing was the Earth subsystems. So you guys did a really good job in this discussion forum. And I wanted you to, whoops, I have it on the wrong side. Hang on. Let's try it this way. No, it's still, sorry. Let's just not do that then. Let's just maximize this, and I'll just walk you through this. So there are basically 4 subsystems on the Earth, and you folks nailed it. When you look at the Earth is a blue planet, and it's a blue planet because the majority of the Earth is covered in water, which is included in what's called the hydrosphere. So the hydrosphere includes water in oceans, water in lakes and streams. It does not include water in the atmosphere, though. The atmosphere is considered a separate subsystem, and the atmosphere is sort of the thin envelope of gases that surround the Earth, and that includes air masses like weather that create weather patterns and things of that nature. all of the organisms on Earth are encompassed within what's called the biosphere, or the sphere of life. And that includes things like alligators, like you see in this picture here, but it also includes like whales and microorganisms that decompose plant life and things all across the globe. And then, of course, everything sits on the solid Earth, which is called the lithosphere, which means sphere of rock. And that's the solid Earth. And all four of these things are happening simultaneously. And as you saw in your discussion forum, they can impact each other, right? So take, for example, the huge wildfires that happened recently in Australia, right? Those are weather patterns that are a result of changes in the atmosphere that resulted in the right conditions for an event that greatly impacted the biosphere, right, in the area. So what are powering all of these subsystems? And the answer is twofold. The first is the sun. So the sun absolutely powers the atmosphere, and it also powers the hydrosphere. And in turn, the sun basically is also is used for the development of photosynthesis, which is the basis for most of the food webs on Earth in the biosphere. What is not encompassed, though, what the second source of energy really is for the Earth's subsystems is the Earth's own internal heat. So the core of the Earth is an iron-nickel blend, but it also has an appreciable amount of uranium. And so uranium will decay over time into lead, and as that happens, it will release tremendous amounts of heat. So the core of the Earth is like 12,000 degrees Fahrenheit, and it, as you saw in chapter 1, it drives convection in the Earth's mantle, and convection in the mantle results in motion of the crust, which results in the occurrence of earthquakes and volcanic eruptions. So that lithospheric piece, right, impacts the biosphere, right, because organisms are impacted by earthquakes and by volcanic eruptions. And in turn, volcanic eruptions contribute carbon dioxide and water vapor and other gases into the atmosphere. All right. So that was that particular portion of your discussion forum.